Good morning, respected Director Sir, Honorable HOD, esteemed convener, distinguished speaker, dear colleagues and participants. It gives us immense pleasure to welcome you all to the 5 days online FDP on Intelligent Computing Techniques and its Engineering Application ICTE 2025 organized by Department of Computer Science and Engineering of College of Engineering and Management, Kolaghat. This program is a wonderful opportunity for us to enhance our skills and knowledge, and we are excited to embark on this learning journey together. Before we begin, let us seek the blessings of Goddess Saraswati, the embodiment of knowledge and wisdom, for successful and enriching sessions ahead. We all now begin with the auspicious Saraswati Vandana.
या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहाम् हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Thank you for your reverence. We are truly blessed to have the blessings of Goddess Saraswati today as we start this enriching program. Now, it is my honor to invite the head of the Department of Computer Science and Engineering to address us. The HOD has been a guiding light for our department, always encouraging us to push the boundaries of excellence. Please join me in welcoming Dr. Alok Ranjan Pal, our esteemed HOD, to share his thoughts with us.
Hello. Sorry for the inconvenience. It was completely unfortunate and beyond our control, but still we are sorry. Anyway, Namaskar, good morning. I, Alok Ranjan Pal, from the Department of CSE of the College of Engineering and Management, Kolaghat, bid you all a warm welcome to this virtual platform. This department was started in 1998 with an intake of 40. After several phases of increment, at present this intake is 240. Our department, just in few sentences, the department is NBA accredited since 2017. The department boasts about its excellent faculty members with extensive teaching experience, state-of-the-art laboratories, R&D section, innovation council, coding club, departmental library, and many more. After completion of BTech from this department, most of the students secure positions in reputed companies, while some other pursue higher education with excellent scores like GATE, GRE, etc. Notable alumni of this department includes professor at IITs, scientists in different research organizations, dignified administrators in different software companies, etc. In one line, in academia, possibly we are not the best, but surely we work hard always to stay very close to it. Thank you, Jai Hind. Madam.
Thank you, Dr. Alok Ranjan Pal, for your insightful words. Your guidance continues to inspire us to strive for excellence in every aspect of academic journey. Next, we have with us the convener of this program, who has worked tirelessly behind the scenes to bring this event together. It is my pleasure to invite Dr. Taposh Kumar Maiti, the convener of this faculty development program, to give the welcome address and give us an overview of the FDP ICTE 2025.
Hello. Hello. Good morning, respected director, HOD, esteemed colleagues, distinguished guests, faculty members, and dear participants. I express my heartiest welcome to you all to this enriching faculty development program on intelligent computing techniques and its engineering applications, ICTEA 2025. It is a pleasure and a privilege to speak as the convener of this program, and I am truly excited about the knowledge sharing, discussion, and interactions that will unfold in the coming days. We really overexcited on overwhelming registration response from almost 20 states of India. Not only India, abroad countries like Oman, Pakistan, China, we have got registration response. Total 1,540 candidates from 500 plus organizations registered for this FDP. Among of them, 57 professors, 153 associate professors, 1,117 assistant professors, 61 PhD scholars, 20 PG scholars, 60 students, and other 72. It is beyond our expectations that faculties from almost 200 various departments have shown their interest in this FDP. Participants from English, mathematics, agriculture, fashion technology, textile, chemistry, physics, biotechnology, marine engineering, mechanical engineering, electronics, data science, electrical, music, in fact, nursing, mining, radiology, political science, computer science, AIML, IoT, and also from electronics. We have united a distinguished panel of experts from academia and industry who will share their insights and expertise on various aspects of intelligent computing, including deep learning in medicine, transformative landscape of generative AI, software migration for industrial automation, harnessing quantum computing and generative AI, blockchain technology, and cyber threats, and so forth. I urge all participants to actively engage in the discussions, share their experiences, and contribute to the collective learning process. Finally, I would like to express my heartfelt gratitude to our management, experts, and resource persons for their support and collaboration in making this event possible. Their commitment to fostering a culture of continuous learning and academic excellence is what makes the programs like this so impactful. I wish you all a fruitful and enriching learning experience. Thank you. Thank you all. Over to
Thank you, Dr. Tapush Kumar Maiti, for sharing the vision of this program with us. We are all excited about the opportunities that this FDP presents, and we look forward to the valuable sessions ahead. Now, we have the privilege of hearing from our guidance force of the institution, the director, who has always been a source of inspiration. I am honored to invite our respected director, Dr. Dilip Kumar Gayan, to address us.
Good morning to all the distinguished guests, eminent speaker, faculty member, and my dear participants. It gives me immense pleasure to welcome you all to the inaugurations of this one-week faculty development program on intelligent computing techniques and its engineering applications, ICTEA 2025, organized by Department of Computer Science and Engineering of our college. As we embark on this academic effort, let me briefly reflect on the legacy of the College of Engineering Management, Kolkata. Established in 1998 with the assistance of West Bengal Power Development Corporations Limited, the college incurred its foundation to the visionary effort of Dr. Shankar Sen, the then Minister of Power, Government of West Bengal. Dr. Sen, a renowned academician and an eminent authority in the field of electrical engineering, laid the groundwork for these institutions, dreaming it as a center of excellence in technical education. Our institution stands tall as a premier center for engineering education, affiliated with Maulana Abul Kalam Azad University of Technology and approved by the All India Council for Technical Education. Spread over 32.6 acres of green land within the premises of Kolkata Thermal Power Plant Township. CMK has been a pioneer in providing quality education and fostering innovations. With the active support of the Vidyasagar Society for Integrated Learning, VSIL, chaired by the Honorable MIC Power, Government of West Bengal, Sri Arup Biswas, we have built a robust infrastructure and a strong team of dedicated faculty members who are shaping the engineers of tomorrow. The theme of this FDP, intelligent computing techniques and its engineering applications, have been more relevant in today's rapidly advancing technological landscape. The intelligent computing is the cornerstone of transformating technology like artificial intelligence, machine learning, data analytics, and the Internet of Things. These innovations are redefining industries, reshaping economics, and transforming how we live and work. This FDP has been precisely designed to provide theoretical and practical insight into these cutting-edge computing techniques. The objective of these programs are threefold. First one, enhancing knowledge and skill to equip educators with the tools to address the need of a changing academic and industrial environment. Second one, providing theoretical and practical exposure to emerging technology and their engineering applications. Third one, encouraging research and innovations to pave the way for groundbreaking advancement in computer science and engineering. We are honored to have esteemed panel of speakers joining us, including distinguished academicians and industrial professionals from premier institutes and organizations such as IIT Kanpur, ISI Kolkata, IIT Patna, ABB Corporate Research Center Bangalore, Samsung R&D, and Cognizant Technology Solution Europe, among others. This week-long journey is not just an opportunity for learners, but also a platform to foster collaboration and exchange ideas. I urge all the participants to actively engage in the sessions, ask questions, and share perspective to maximize the benefit of this program. Before I conclude, let me express my gratitude to the Department of Computer Science and Engineering, led by Dr. Alok Ranjan Pal, the program coordinator, and the conveners, and all those who have worked tirelessly to organize this activity. Your dedications and hard work have made this event possible. Let us commit ourselves to make this FDPA the sound success. Together, let us explore the frontier of intelligent computing and contribute to the advancements of knowledge and innovation in engineering. Once again, I welcome you all and wish you a fruitful and enriching week ahead. Thank you all.
Thank you, Dr. Dilip Kumar Gayan, for your encouraging words and for continuously motivating us to be our best. We are truly fortunate to have such visionary leadership. As we come to the end of this inaugural session, we would like to express our heartfelt gratitude to all the dignitaries for their inspiring words and to each one of you for being part of this wonderful journey. Let us all remain engaged and open to the new ideas and insights that will surely make this FDP a truly enriching experience. We are now ready to dive into the core of today's forenoon session, and we couldn't be more excited about the learning that awaits us. With that, I would like to invite our esteemed speaker, Dr. Debobroto Samanto, who will enlighten us with his knowledge and experience. Now, a very brief introduction about our speaker.
Dr. Debobroto Samanto works as a program head and an assistant professor at the Department of Computing and Information Technologies, RIT Kosovo, Rochester Institute of Technology, RIT Global Campus, Kosovo, Europe. He obtained his PhD in Computer Science and Engineering from the National Institute of Technology, Durgapur, India, in SAR Image Processing. He has a vast experience in several subfields of image processing. He has supervised 6 consultancy projects and guided 4 PhD scholars in his research domain. He owns 22 patents and 2 copyrights. He has authored and co-authored over 250 research papers in several reputed international journals and conferences. Thank you.
We are truly privileged to have Dr. Debobroto Samanto with us today. Without further delay, I request Dr. Samanto to begin today's session. Sir, please.
Am I audible? Yes, sir. Yes, sir. Yes, sir. Okay. Hope my screen is visible. Yes, sir. Okay. Yes, sir. Yes.
Good morning all. Sorry for that technical features and late starting for these particular situations. Thanks all of you to be your patience, and I will try to finish before the time slot, because I understand that pre-launch session is slightly difficult to convince the people, and we can try my best to manage these situations. Basically, today is my sessions in the part of prediction model. Basically, prediction model is day by day is more demand in different type of activity of either the medical sectors, either the industrial situations. So basically, my focus to different type of project, what exactly we are doing in different type of categorized, and somehow I try to project my hands-on session today also, depends on my simulator. Before start the sessions, one small already madam represented on my situations, my expertise. I am basically IBM digital badge holders in the terms of this data security process, IBM cloud, and that text classification process. And I have two author books in the part of deeply in AI ML based work, which is already available in the part of different type of organizations for the part of textbooks also. I have more than 3,000 Google Scholar citations. This is the my small background. I am from Kosovo, but now today I came these prestigious organizations in physical mode because of my vacation time. I physically visited for my research sessions in Finland, Germany, Austria, Morocco, North Macedonia, and Brazil. I have cyber security, data security process maximum level of badge from the US government. I am the first Indian who work in Kosovo, so Prime Minister of the Kosovo appreciate me. And frequently we have some research sessions in NIT Raurkela and IIT Kharagpur also. This is my small background. This is my situations of Kosovo. RIT is fully snow, is completely what I can say that minus 10 to 15 degree temperatures in winter time. It's very difficult to come out from the college, so it's challenging to solve the situations with respect to AI ML based work. That since the prediction model is huge demand in European environment, that basically today I want to project one by one example based project what exactly I involved and my team is involved, and try to give some hands-on projection also. This is my team. Most of the UG, PG, PhD and postdoc students are there. They are directly involved in the part of different type of project. Basically, in my organizations, there is no assignment at all. They have to finish one of the small project, and that project should be approved in either government of Kosovo or some industry. Then only they can get the point and score for the next academic year or the next semester process. So this is the way we improve. We encourage the people to involve themselves in the part of the different type of project and solutions, which is, you can say, that sustainable development of the process. Before my is long journey of these two people who are inspire me at always. One is that Professor Venugopal from Karnataka. I think most of the computer science book from Venugopal Care, and another one ma'am from ISC Bank, from ISI Kolkata, Sangeeta ma'am. Basically, these two people who encourage me to move on in this long journey process. Now we can start today's topic. What exactly my focus, my today agenda depends on that medical prediction model process. Day by day, the people, they want to move on the automation systems. As we know that a lot of different type of difficulties to trust issue in the doctor to the patients, or the environment to the patients, or the situation not support to directly access to the doctors also. In European environment, most of the, if you search in the Google, the huge lack of the medical support, either doctor or nurse, is a huge demand. It is not available that much. So it's very difficult to one-to-one access is impossible. So that's just that environment. We need some automation systems. We need some prediction model to can support that medical situations, uncertainty situations. And that since day by day, it's a huge demand in that particular environment. Basically, we can say that different type of disease diagnosis systems, that today I have to give some experiment data also, that how the people they're thinking, because one thing is -10-degree temperatures, people not too easy to come out a long journey to access the doctors or access the environment, medical support systems, but people want to predict their diagnosis systems. So that cases, the deep learning based environment can give the better support in these cases. What exactly we observe that different type of data access, or we can see that complexity of data pattern, if we access easily, we can predict. Not 100% is not possible. Deep learning can support, but we can go that 85 to 95% support from this particular prediction model process. Day by day are huge applications. Day by day are huge demand in the part of this, either the cancer base, either the different type of disease like diabetic patients. Last 2 years before, the huge demand for that COVID situations. Nowadays, another different type of disease is coming. People are trying to prediction that way, but we believe that that deep learning can support that level. Yes, there are some challenges, there are some difficulties also is there. One is that the medical data is very highly sensitive. One of the small example, I am in Kosovo, I am working there, but it's very difficult to access the European Union medical data, because every country they have different type of law, different type of accessibility permissions, so it's very difficult. But from that Kosovo, I am easily access the Niemens hospitals in from Bangalore. We have some collaboration. Previously, I work in Christ University, and from there I collaborate a different way, which can give the better result in the terms of this highly sensitive medical data process to access this type of data process. And even though it's 2025, people are move on in the AI base, but there is some trust issue also is available in the part of AI model. Basically, some patients, they don't want to go this directly in AI model. They want to access the direct doctor to one situations. So that type of challenges, we have to be motivate them to move on that way. Then only it is possible to create a different type of prediction process. One of the prediction model, what exactly today we want to demonstrate, or what exactly our main motto, main target, in 3 different categories. One of this thing is that CNN model. Obviously, I think most of the researchers blindly they start their research in the part of the CNN model. And secondly is that RNN and GAN process. Yes, that RNN and GAN, we will go out slowly that why this currently research move on in the part of GAN process. They want to remove the CNN process. We will give some experiment data and we will give some examples also. If you move on this right sides, this basics diagram, there is a lot of dependency for this particular prediction model. Basically, one of the most important things is that data. Whatever data you have, whatever data collections you are involved to this particular project. Before start that particular patients have old history of the particular process. Very simple thing is that one of the example that nowadays the diabetic patient, high blood pressures, blood sugars is 80 to 90% from your generation wise gene dependency. Maybe your father, your old generations they have, it's continuously come by the generation 3 is coming. 80% is depends on that one. So that medical literature part also is important to build your current deep learning model also. This is one of the new features what exactly we installed to our software process. Second thing is that every patients they are fluctuating to move on at different organizations. One small example that currently we have one of the patients under our surveillance in the part of deep learning model. Last 1 year, uh, he visited more than 11 doctors because of that diabetic patient. So he is confused. He mentally disrupted to different type of medical environment. So now we have to try to collect the 11 doctor centers what exactly his information are available there. So we are trying to create a normal platform where all the data can be involved and available for that process. And second thing is that uh, different type of lab data. Basically, yes, the India have the different architectures of this pathological laboratory is a huge business policy, huge hierarchy systems. But in European environment, very straightforward. So if it is requirement, they will do the lab treatment. Otherwise, they will not suggest you to do the lab treatment process. So that is a different case to easy to access the particular which is the requirement for the patients to create the deep learning model particular disease. It's easy to access, but that Indian environment we have the huge lab data set. Maybe from there 1 or 2 data is required for this particular disease process. That is the one of the big challenge to move on. Now the question is why the CNN is the most demandable in the Indian academic environment or the Indian research environment process. The main reason is that directly we can access the CT scan data. And I remember that more than 10 years before when I started my image processing research. So default people are telling that, oh, you can go for the cancer detections, you can go for the CT scan data or X-ray data, damage cell detection process. So is a huge demand. So that's on that the default the creator they involved in CNN model 3 things. One is the X-ray data, one is the CT scan data, and the MRI data. That's why CNN model is huge demand, easy to access as a ground level to higher level to create a unique AI model process. If you move on the RNN, some cases that CNN is not supported at all, like the effective ECG data, EEG data also, which is better result than the CNN model with respect to RNN directly. It will be involved that heart disease. Today, one of the data set we have that prediction of heart attack, or we can say that damage of the heart prediction model. We can show it's fully depends on the RNN process. And last, slow, costly, and it will be depends on different type of data sets involved in a huge hidden layer is available inside the GAN process. So most of the people they are avoiding this process, but we have one of the effective result. We got a good prediction model with the GAN process. That also we will showcase you that European environment people they want a different type of structure of MRI scan data using the GAN level also. So today I will showcase you few experiment, few hands-on, and also interact depends on the people what exactly their request, their interest. So in between I will talk, I will allow you to talk and ask the questions to move on the process. So this is the overall idea to project these 1.5 hour sessions. Now we can move on some basics demonstrations that how we can work that this AI model. Basically, most of the people they are thinking that AI model is very difficult, very complicated. Yes, it is difficult, complicated, but we can go slowly to the fit a model with bias, unbiased, different type of data set, different type of prediction model to create. So first we can move on the basics things, what exactly that 2 input and 1 of the output process is this very easy to understand to create a small prediction model. Then we can move on that 3 input, 4 input, then 100 input, 1000 input type of process we can increase one by one. So if you observe this particular experiment, particular example of that, was very easy to understand. 0 0, it is 0. If anything 1 is there, it will be 1. That means positive, or we can say that yes, it should be the output will come if any one input is 1. So if you want to process that cases, we want to create some Google Colab platform, which is easy to execute, because if you have the difficulty to the infrastructures, is easy to access in the part of this Google Colab to execute any type of AI model, because is a huge fast platform to execute the process. So for that cases, very simple thing is that we design a input depends on our input models and what exactly our output. Then we can create with bias process model prediction, that if this the input, automatically we can create the output process. So for that, obviously it's required some libraries, which is that you can say that uh, Python's number with neural network with the bias value calculation process. We just import the process, and as per the questions, we saw that this is our input model. This is our process. So for the reasons, we just declare this basics idea that 0 0 0 1 1 0, just array declaration process. So this is the way we execute this particular input features or input process. And sometimes we have to be calculate the part of this what is the shape size. Obviously it is the 4 only, so 4 and 2 is coming. And also, as that definition of the questions, we define this is our output. If it is 0 0, it is 0, or any 1 is available, it should be the 1. So that cases we create the target output process. So this is the way we have to be define the target output array, 0 1 1 1, and then just we print the shape of the output and just print the value. Now we have to be define the weights. Basically, weights is the another important factors of this particular neural network process. And as it is 4 and 2, so we split 2 2. So 0.1 0.2 is the weighted value, and we print the value is the 0.1 0.2. This is the way we calculate, and then we execute the bias process, which is the important part of this technicality. Because sometimes if bias is not fit for this particular model, we have to be changing. So default trial process, we start 0 1 0 2 0 3. We saw that 0 3 is giving the effective result, so we can fix this bias weighted in the 0.3 process. Landing net, obviously middle of this peak value, so it is 0.05. And then we are using the sigmoid function, which is the most important factor, because sigmoid functions default is giving the linearly way, smoothly way to give the fit of the model. And obviously if we call the sigmoid function, obviously default we have to execute the reversed or derivative of the sigmoid functions to execute the reverse engineering value or the error calculation of this particular process. Then we can execute that, store the different type of categorized. We always range the 10,000 to execute the process, and we want to put in that weight plus bias value to create the feed words of the input value, and then we want to store the same value inside the output. After that, we calculate the error process, and if the error is that negative, so it's that means we have to be get the effective result of this neural network of the bias statement. So that means bias is fit for this process, so error is negative, that means there is nothing of this process. Now we just calculate the derivative value. After that, we have to be install the features in this particular model with executing this dot product of the input of the variant process, and then we add one by one each weighted level in each process. After that, finally we call our model. If we show that we are giving that 1 and 0 and we are getting that particular value, again we are giving that 1 and 1, we are getting the value, and 0 and 0. Basically, as per the model process, below 0.5, considered as a 0. So just we can check that if it is 0 is value, so it is 0.3. So that means our model is fit, and other all the values 1 is available. So this is the way we are getting that our this model, which is supported directly to this particular process with bias way. So this is the way we are executing these particular structures with these particular sigmoid functions. And the two things is important for this value. One is this weighted value, one is the bias value. So these two things, if we remember, so automatically our model is supported this small number of input. Now we have to be increase the input. So just next level. So we just fit a model with the ground level. Now we have to be improved to the number of things. There is the number of things how we can define. It's very easiest way that we are collecting the few information from the doctors that 4 different type of parameters, 4 different type of disease identification process. One is that loss of smell, where basically sometimes people cannot smell the particular different categorized. Suddenly within 15 days a huge weight loss, within 7 days huge weight loss happen. Continuously people is that runny nose, basically in the changing of the seasons, in the winter part it will be common things, and huge body pain, the joint pain. So if it is this is the 4 data which we collected from the doctors, and after the doctor prediction support we create this particular data set for that if it is this particular 1001, if it is 2 parties that positive, either you have the body pain or the loss of the smell, obviously we can say that you have that some particular virus. It's not COVID, it's different things, but we can say that you are the have a different type of virus affections of this particular process. And only you have the nose is running nose, but other part is 0. It's a normal health issue. It's not that any type of virus you have to affect it. But if you have that continuously body pain, but you don't have the other 3 thing is 0, so we also can say that just you have some vitamin C or the calcium less, so you have to improve that part. So this is the way this particular 4 categorized, and that you are effective of the virus or not. This part is given by the doctors. Then we create this particular chart sheet, and now we want to introduce this inside that coding part to create our model, our neural network model process. Then we can move on the next type of activity, what exactly we have to be move on that. Just I have to open that file because I already create all the files, so easy to minimize my time slot. And these cases we saw that only the input is 4 different type of categories. It will be increased 2, 4, 8. Then it will be today I will show you more than 10 type of parameters which can execute the process. Is the same way, same sigmoid functions. It is not that much difficult to execute with the bias and the weight value. The same thing, just we increase the number of input and we predefine of the output, and then we want to call one by one. So basically it's a very simple thing, same thing, just is the normal array process. We execute one by one, define the input data sets. Then we want to execute that, put the value that what exactly our target output is the process. And we saw that it is that 4 different type of categories. So we put that output target 8:1 categories process, and it is 4 different type of weight value. That means 0.1, 0.2, 0.3, 0.4. Same thing, we put the bias value as a 0.3, and learning date, it's always the middle part. That's just we always put the 0.05 process. We define the sigmoid functions. After that, we define that derivative of the sigmoid function, just reverse engineering process to calculate these things. And 10,000 epoch to easy to train our machines, because as it is more than 6 different type of, that means 8 different type of inputs are available. So 10,000 epoch is standardized to easy to calculate process. Sometimes we have to be cross check the our error is positive or the negative, or what exactly the error is coming to after adding the bias value. That's also always we have to print that in between the error part, and then we just call these delta functions to execute the particular value, and then we give the one by one the parameters, input parameters. We can prediction the value, again input parameters, prediction the value, and we check that obviously just we tested that one or two value, and we observe that if it is 1001, so we can go that 1001 is that positive. So just we want to see that value what exactly is coming or not. Yes, 0.6. So that means more than 0.5 is 1. So that means our prediction model is giving the accurate result in this particular segment function. If the input value we increase that number 3 to number 8, we can get the better result. So this is the way you can execute one by one. It's easy to calculate the number of value, and we can move on the next example. Another one is very easy because nowadays people they are trying to give that the Indian environment that a lot of diabetic patients day by day nowadays execute, and we try to minimize the parameters of the diabetic patients, so easy to calculate. So basically diabetic patients more than 15 to 16 parameters are available, but what we observed in the last 2 years, Niemann's hospitals they have a few data set. What exactly we observed that there's 3 major things if we observe is we can predict, because diabetic patients 80% is coming from the your old generations. That means father to son, son to next sons, like that, grandfather, grandmothers, or that tree wise. It is coming from one to the next generations. For that reasons, it's always be the minimize the yes or no, true or false, the diabetic patients or no prediction model. And that case is the 3 major important things that are smoking and obesity and exercise. 3 things is the important factors if you are telling creating a data set for the diabetic patients. 3 things is easy to be processed. Basically, these particular structures, why we minimize the another main reason is that if you observe our old entire prediction model process. So this patient's history and the exam. So this part is that major effective the diabetic patient calculation process. So these things automatically we can got the 50% to 80% result is accurate if you have that old history data you have. Basically, maybe I went for the doctor process. Can we check the diabetic patients before they have data said that yes, my father have the diabetic patients. It's chance to be 50 to 80% that you have the diabetic patients. And then we have the 3 major conditions: smoking, exercise. Exercise means is not that go to the gym. Exercise means that you have to be walk every day, minimum 1,000 steps is enough to fit your exercise process. And you can do basically, if you know the balloons that try to create a balloons by your own airs in the part of the day 1 morning and evening. So your heartbeat and that diabetic pressures will be improved in the part of this data set. So this is the way we have some experiment process, and we got these particular structures, and we minimize this data in these 3 categories. The same thing, if you want to create this model, it's very simple that we have to minimize the part of the process with this array process. I just open this diabetic patients, this one. Depends on the internet speed we can be accessed. These are things that as per that input process 0 1 0 0 0 1, that all inputs we are giving that particular process as a our input array, and then we can define our output process, basically what exactly our things, and we can receive it as 5:1, and as it is 3 part of this process. We put the weightage and the learning process with this 0.05. Then same thing, sigmoid function, because why I use the sigmoid function, it is smoothly changing the value in the part of the each epoch level. So, and we tested the result, and we saw that each epoch value, because sometimes we have to be get some predictions idea that our model is going proper way or not using this epoch data also. So that is sometimes we have to be print this epoch data before you conclude our particular process. Basically, always we check that error calculation. If it is negative, that means our epoch range is proper way. So that just no need to be printed each and every times to get the better result. Just we tested one result that 001. 001 is result is 0 or negative for the diabetic patients, and we saw it is less than 0.5. So it is, that means our model is supported of these particular structures. And if we test 111, that means 1111. So we saw that diabetic patient is that effectively he is in the effect. So if we execute this, and we got that more than 0.5, so that means our prediction model is correct in these cases. So this is the way we just create a small data set to depends on that without bias process, and day by day the people they move on in the different type of infrastructure process to create the bigger data set, bigger models. Before that, you have to fit a small model, then you can be encourage hybrid way. You can fit different structures. I will showcase you another example how to fit the hybrid model to get a huge data set to execute that process. And so I create the small model to execute this. Basically, yes, it's more than half an hour. Is now we have to be do some activity that how this my audience what exactly they need. Basically, I just execute one of the small things which is easy to be part. Just you try to visit the menti.com and give this code. Just you open your mobile phone or the desktop or the laptop. Just to open this menti.com and give this code 43136235. And I need some idea from your audience side what exactly they need or what exactly they want to start the initial stage of the research, most cases. So we can wait for 2 to 3 minutes to effectively support for the audience side. I just request the audience, please go to the menti.com, menti.com, and the code is 43136235. Everything is visible in the screen. Hope it is visible for all of you. I just request you, please go to the menti.com, use this code 43136235. As we observe that more than 500 audience are effectively joining these particular sessions. I appreciate all of you. But also we need some create that data set of the process to execute the next level of the execution process. I just request you to move on this process, menti.com, and give this code 43136235. Till now,
Sir, what is the spelling, sir? MEN?
MENTI. Just is visible in the screen. MENTI, menti.com. The first line, the code 43136235. Yes, already one people is uh, reply. We can wait for another few minutes. So students or the other audience, they can be. I request the audience please unmute, so otherwise it will be noise. Partho Basu, I request you please unmute yourself, so it is easy for that. Not noise. Thank you. Okay, yes, very good. 4 people apply. I request the other audience, because as per visibility, more than 500 people join this session. So I request people to actively participate in this structure, so we can use this data for that upcoming some experimental data also. Okay, very nice. 7 people reply strongly. I can wait another 1 or 2 minutes. Please go to menti.com, use the code 43136235. 7 people reply. I request the other audience, if it is possible, organizer, can you put this code in the chat box so people can be get this one? Menti.com. The code is 43136235. Okay, 12 people actively reply. We can wait another 1 or 2 minutes, because I need minimum 25 people data, so that only I can create the data set for this particular execution process, that how the hybrid model can be support a better way. 16 people reply, very good, perfect. I can wait for a few minutes. I request the audience, please go to the menti.com, menti.com, use the code 43136235. And more than 500 people join by YouTube live and the normal Google Meet total. I request you people should be actively attend these particular structures. 16 people reply. Just go to the menti.com, use this code 43136235. 70 people reply. The code is menti.com. The number is 43136235. Just visible to the slide. The first line is that menti.com, and the code is 43136235. We can wait another few minutes. Most of the lot of people, they reply in the YouTube. I appreciate for that, the audience. I saw that few people, they love the CNN, is the very easy way. I appreciate for that. Hope it will be increased, because the code and that link is visible in the YouTube live also. I request the people, please kindly join. I can wait another 1 or 2 minutes. "17 people reply. I need minimum 25 people. Lot of people, they reply in the chat box and the YouTube live. Yes, people are doing very good. 19. I need another few audience. I request the participant, please open the menti.com and they give the code 43136235. Four three one three, no, 6235. 6235. I think you typed wrongly. Dr. Patil. please give the proper code 43136235. Oh, 28 people reply. Very good. I appreciate the audience. I can wait another 1 or 2 minutes. I understand that it's going to be the less work. Oh, 33. That means the audience is so active. I appreciate all of you. The code is 43136235. Okay. So till now, what exactly we observed that 40 people out of 40 people and few people they already reply in the YouTube chat box. Most of the people they love the CNN. Yes. So obviously the CNN is the easiest way to involve or inbuilt and access the data directly from that X-ray data to the directly involve the model. But we have a different platform. I will showcase you one by one experiment data, project based, what exactly I worked last 2 years in European environment. And then you will be move on to CNN to directly GAN process that we can promise. Oh, it's cross half century, 50 people actively reply. I appreciate all of you. Okay, we can wait another 1 minute because if I close this window, the code will be not work. Better I can wait for another 1 or 2 minutes. Who are not reply, I request the audience, please go to the menti.com. The code is 43136235. That means actively participate till now 58 people. I appreciate that particular participants. Obviously, we will create some fruitful environment to create a new your own hybrid model end of these particular sessions. Okay, now we can go to the next part. I just close these. I will come. I'll use this data to create our own model before we can go for the next project. Basically, this is the one of the project I worked last 1 year 4 months. Me and my team they are working directly into this particular project. And first to understand, then I will explain what exactly we are doing that part.
Is it any issue? Hello? Is it any issue? Is it audible, sir? Yes, sir, is it audible? Hello? Yeah, now it's audible. Now it's audible. Yes, sure, sir. Sir, am I audible, sir?
Yes,
sir?
my video is audible?
Your video is, I can see the video as well as you are audible, sir.
Okay. Okay. Basically, this is the one of the what I can say the structure of the Kosovo government. They are trying to install this port in different type of places to execute these structures. In February, they have the election process, so they want to install this medical port of, in different type of cities, like the ATM centers, or you can say that in India, different places, they have the option to give the 5 rupee coin and they get 20 liter of water. Like that, this port they're installing different places. Basically, European people they have a different type of mind setup. They don't have a time to spend a huge time to diagnosis process, and what they want, maybe they visit in the center, they want to travel, they want to market or something, just they enter the port, they using the Instagram or something, they're busy for 10 to 15 minutes maximum, they stay here, and after half an hour they will got the entire report, depends on the health situations. So that is the upcoming future is coming in the care pod concept, and it's a huge costly structures for one patient. What exactly the European environment as they convert the Indian economic systems, more than 35,000 for the one persons, it's too costly now. We have a big challenge to minimize the cost to install the Asiatic environment, and we can get in number of people can access these particular structures. If you observe that already the government of India, they installed one of the AI based breast cancer prediction robot couple of months before in New Delhi, and 94% accuracy is coming for the breast cancers. So that means already is Indian healthcare systems is going to improve in the part of AI based learning process. So this is the one of the project. This is the first batch of my RIT Kosovo students. They directly involved in this type of activity to the X-ray data, scanning data, eyeball density, your skin image. This entire data set they are processing and they're trying to create the model. So this is the one of the project what exactly we involve in couple of months to execute the process. Another one project. First we give some experiment what exactly I involved with my team, and then I will come to the theoretical part and the hands-on sessions. How will this project involve in the prediction model in the AI-based process? Basically, one of the Poland, the Poland of the Nordic zone, most of the depression people are there. Is a huge. If you search in the Google, a lot of people going suicide in the Poland environment. One of the insurance company they observe that basically the old age people, the medical claim or medical bill is too much high, and basically European environment that government pay the insurance process is as without insurance people cannot live in European environment because it's a huge costly, and who will take care with your old age environment. And the main project is that the observations come like that way, that old age people frequently sick or fever, the temperature is too high. After the secure of that antibiotic or something, they improve their health structures. But frequently they are sick and go to the ambulance, go to the hospital. Is a huge bill. And last 3 years, that particular insurance company increased their too much bill, so it's a huge loss for that. Then they call multiple people, they call the doctors, they call that lot of medical scientists who can execute this, and they told that all people are fit, and no idea why these people are frequently sick every month, maybe 3 to 4 times. It's really a surprise for that. Then they call for us. We went there. We went with my team, and what exactly our observations is very interesting process. Most of the European old age people are alone. They are kids in city for the working process, and entire house is controlled by the IoT device, the smart house. Everything, either it is opening the garage, heating systems, cooking systems, hot water, uh, air cooler systems, refrigerators, washing machine, everything controlled by the particular part of the IoT device. One thing is that people are alone, nobody take care, so they need the automatic systems. Their son, their kids, they are in the part of the uh, city, and they are observing with the mobile phone how my parents are there. I also installed my village, my parents' house, one of the small IoT device to predict my parents are mentally healthy or not physically, mentally healthy or not. That's a different thing. I'll focus that project also. And our observations, what exactly the main reasons? Main reason is that one of the hacker, or you can say that data security people, the 11 p.m. to 3 a.m. that duration, they change the AC data, air condition temperature they are minimizing, and the old age people are sick because of the low temperatures of that particular continuously durations. And morning they have to be go to the particular ambulance and transfer to the process of the treatment techniques process. So this is the basically all the data put in the cloud. People are running for the 5G, people are running for the IoT device, people are put everything in the cloud, and that data security process easily, it's a very easy way to collect that data, and change depends on your requirement. And our suggestions that if you have the air condition in your house, please reset your air conditions, otherwise people can easily hack your air condition and change your temperatures, maybe you don't know. So this is the way we give this our prediction model, and we observe the data process, and after 3 months we give the solutions. And the government of Poland and the insurance company, they appreciate our particular project. And when we execute, we give the outcome solutions, and the architectures of our models define like this way. One is that we get the automatic data, real-time analysis, basic sigmoid function process, and we observe that particular 11 p.m. to 3 a.m. data patterns are similar to this particular temperature process, so that easily we can predict our analytical process. And obviously we use the neural network, so obviously it will be part of the AI process supporting to give this result. After the result, finally the oldest people are happy, and frequently we have a team, and that every day morning, that few oldest people till now they are sending the WhatsApp thank you message to that. It's a huge revolutions happen in the part of this normal fever to that control the temperature process. And now people are so happy, and we submitted our project end of that process. For these particular things, one of the big challenge, what exactly we observe, the major part is data considerations. What type of data? Because for the prediction model or the medical prediction process, it's a huge changing. If one data is fake or not supported, or manually you modify the data. So that since the data consistency is the major factor of your own prediction process. Maybe you can say that your data set supported of your rare disease process, or you can say that sometimes that when you're cleaning the data, the lot of data is removed. Your data cannot support direct normalization process, or there is no numerical features of the medical data, because a lot of the nurse, lot of the medical support team, they collect the data as a voice, as a text message, as a normal writing process. There's no numerical data. So that is a big challenge to convert a proper data set for the prediction model. So that is as our expertise, or we observe. Basically, one thing is that check your data set of A4 score, or you can check how the balance sensitivity depends on better effective way to support to your prediction model to your data set. And finally, obviously, it's my suggestions, before prediction model, you try to create some binary classifications, which is the most important factor, and it will be effective, depends on your activity process. Now we split the structures. Basically, the data set, the structure is different way. Then only you can be create the 100%, not 100%, 95, 97 or 98% accuracy of your prediction model, and that is important. For that cases, we create the any medical prediction process in 3 level. One is the patient's level, visit level, event level. That I told that I have one of the patient in under our surveillance last 1 year. 11 doctors he visited. He is frustrated for the diabetic patients, and every time we are trying to collect the data from different model, different process, and we create a centralized platform where we can store all the data, and then we can filter one by one. Second thing is that that few disease directly depends on your last 3 months activity. One small example that you know that every year end of the particular year, January and the December, this slot, lot of new disease is visible. Is this either it's China, either it is Asiatic environment, either is a Nordic zone, depends on your activity, what the last couple of the days, what exactly your activity, and it will be used effect to your medical disease environment also. So that is always we will give one parameters is the event level, what exactly you did the last 15 days or last couple of days, your activity. That also one of the parameter to build your strong data set of your project. Now we'll move on the few inbuilt features that why the people they love CNN, why the people they likes more CNN day by day, and that all the basics research can be solved in this particular platform. So basically, the CNN have the major 5 factors. One is the convolutional layer, one is that ReLU pooling layer, dense layer, and the dropout. So these cases, most of the image features, most of the filter features, most of the hidden layer, easily you can build, easily you can be effective in the part of these particular structures. For a small example, that we know that when we put the normal image to your computer systems, obviously the huge noise is there. We have to remove the noise. So we use the different type of filter. Sobel, kernel, lot of filters we use. But when we use the filter, we use the different type of mask, 3x3, 5x5, 7x7. But basically, for my last 10 years experiment, what my observations that I never use this type of small mask. I use a huge mask, 7x7. I don't know why, but what we did that To minimize the time complexity, I use the 7+7 mask, and I have my own algorithms. If you search the Google Samantha mask, it is available, and that is we got the adaptively changing the process of the filtering process. So that is one of the effective result. For that, I am using the 7+7 mask for this under CNN process. Another one advantage of this that any medical image analysis sometimes they have a drawback to continuous data. Continuous data means maybe one patient today you have the 10,000 X-ray chest X-ray data. After 15 days, maybe it is 5 or 6. After 1 month, again 10,000 data. So if this continuous data set you are frequently create a real-time environment CNN, it's really difficult. So that cases we have to be move on in the GAN process. They can give some informative way to the process of that supporting of the situations. This is the one of the complete CNN code. I will give you this sample code. Depends on your request. What exactly CNN model? I just change these 5 categories. I change the convection to the layer. Depends on our parameters. We convert the 5x5 filter to 3x3 filters. Some cases, if it is skin disease cancers, we use the 7x7 filter process. Max pooling, same as it is 2x2 is here. We not change anything, but the flattened layer we converted 2D to 3D models. It's not the 1D vectors. It's supported. It's always support the 3D vectors. So we use the new axis process up there. Dense layer, dropout layer is very easy. That default 50% neuron is actively working, and next 50% depends on we change the parameters. We improve these dropout layers, and finally we got the output layers in that actively segment functions using for that. Now, obviously, as per this audience survey, so what is the major advantage? What is the major demand of that? That's why the CNN model is so effectively people they love that part. Either the X-ray research, either the CT scan data research, or that damaged cell detection. The position of the damaged cell is the cell structure. Which part is the damaged cell available? How much percentage damaged cell? So these cases, CNN is the best for that main 3 factors. One is that CNN identify features without manual engineering. Is a huge automations automatically involved in this particular process. Pooling layer is one of the major advantage features of the CNN model, that to recognize the patterns of rigorous process positions in the effectively of any type of CT scan images. And finally, this data set, either small that I told you that only 3 parameters, 8 parameters, 9 parameters also work. And I'll come on the example that I have 10,000 data set. Default, it will be work for CNN model also. So this is the reasons that most of the people, they love to jump inside the CNN model in the process. Another project, basically, it's very interesting project. Depends on that environmental. Basically, in the what I can say that European people, European girls or European women, most of the times they are using the pencil heel. That is too much. Depends on their fashion's concept. And most of the girls and women they have the issue to walk, or that they have disease. They has that damage their structure of the walking style. So Kosovo government before the elections they have some very interesting project, but I can say that they put the camera in the center, like city centers where a lot of people that gathers. They are observing who are walking properly and who are walking not. They identify, and European environment have very less number of crowd, so it's easy to identify. They have the data set, they have the ID card scanning systems, they easily identify who you are, because the less crowd, the proportion is very less, and their data set is very strong, and people are not hide their data. So if this type of work, maybe 2 to 3 minutes, automatically camera extract that particular structures, and they send the SMS to the particular persons. You have these orthopedic features, orthopedic difficulties to work. So try to give your appointment for our medical support. So this is the government one of the small project. Me and my team is working on that. Just one small camera, we check how people are walking. It is normal, cool, or that we using the hill, how the girls they're walking on that way. If it is not normal, we extract features and then we can send the message. So this was the one of the huge architecture in behind to this particular project. The main architectures in this behind is that inbuilt functions, PyChat, CNN. There is two different type of categories. First part is a normal CNN process, where is the input, convolution layer, pooling layer, and the connected layer. This is the very easiest way, but we modify in that level to add some vertical convolutions. We modify the different type of dropout layer inside the review process, and we add some temporal pooling process, because basically women's they can accept their pain, but they don't want to showcase that they have the health issue in the part of the walking process. So they are very, very careful. So that shows it's not require always pooling layer to extract the image extraction process. So some particular we are using that every 18 seconds. I don't know that how this my team they fixed, maybe they tested that 15, 16, 17, 18 seconds to execute that pooling layer. So that means that every 18 seconds the data frame they accepts for that, and then remove it. So these temporal pooling systems are the new things what we introduce inside that CNN process. So this is the one of the new features of that. Basically, we have another one project. It's already is available in India also, the NECO. NECO is the another platform where you can execute your all diagnostic system process depends on structures. Just we can show this 3 minutes small video, then I can come out the next level of the experiment process. So this is the one of the platform where that you can go get all the structures. This Nico is the, but the problem is that Nico is too costly. Depends on the this hardware device, and we are minimizing the structure a different way. And Nico is fully depends on Argon. It's fully, there is no CNN process, and this is the main architectures, but exactly installed inside this Nico process. We have another activity, but we have less time, so we can move on that part. Basically, I just execute one of the small demonstrations. Then we can close this process. That one small thing is that I have one of the data set with that heart prediction model, that which uh, can predict your heart attack prediction process. Depends on the age, and we have real-time data. It's more than 1026 peoples, and we have different type of parameters depends on the doctor prescribes as a heart expertise on that, and there is no what we can say that uh, output, target output, because we don't know the who is that output process. So that cases how we can move on, and how we can be execute this heart prediction process, because day by day we know that that heart prediction is that huge demandable process. If we install this inside a mobile phone, people can check from your process. uh, Basically, this is the one of the things is that we upload these infrastructures in the Kaggle also, so you can easily download this entire data set to the executed process. Depends on your requirement to be execute. The most important thing is that it's a slightly experimental on the pandas and that TensorFlow and the different type of platform. That means we need to be import few factors. Default, it is not available in the inside the Google Colab. So after installing this all the factors and the Keras, if you install, then it will be work, because we need some extra harder expertise to this process. And the prediction model is we can say that 98% accuracy, but we train the model forcefully to 100%, because I want to check that our model is useful or not. So we forcefully changing the three rows data. So only 3 rows out of 1026, only 3 rows data we change, and we got the 100% accuracy. But in the real time, it's not possible. You can if you got the 95 to 97 is enough to your prediction process. So that means no need to forcefully change the data set and try to get the result. So this is the one of the example that how the prediction model can give the effective result in the terms of this process. I will as we have the less time, so we will not execute these things. We can move on the next process. Basically, what is the future? What is the future prediction model or future AI healthcare? There is two things coming. One is the quantum AI and the edge AI, and it will be revolutions. They will be adopted every AI model. So you have to be move on the edge AI process or that quantum AI techniques, which can support everything inside that structure. So this is the one of the useful model structures, upcoming futures of your healthcare prediction process. Before end of the sessions, one of the small example that as an Indians, as a Indian structure, when I was in India, I don't know that how the outside people they observe the Indian cultures and Indian science. I met the Mozilla Foundation's the director. I think Mozilla Firefox, everybody they're using in your laptop or desktop. I met with her in the one of the conference in Kosovo, Dokotech, and next year I was in the stage of the panel member of the AI in the open infrastructure. So there, the director of the Mozilla Steve inspired the AI structure from the one of the Indian Hollywood. So that means we have a resource, we have a huge demand, we have a huge ability. Just you try to adapt and use your structures to modify your idea. So this is the way you can be improve your infrastructures in the different type of AI model. Finally, thank you, College of Engineering and Management, Kolkata. They invite me to showcase my research, my idea with this wonderful audience, and because they actively participate, they actively move on in the different way, and we will keep in touch in the futures for that different type of collaborations. If you want to get my informations, please visit my LinkedIn. We have a lot of research process, upcoming research idea. It will be available there, and we'll keep in touch for in the futures collaborations. Thank you all. Now I hand over to the organizers. If any question from the audience, we can spend another few minutes.
Hello, am I audible, sir?
Yes.
Actually, it's not my question. Actually, I just want to know one thing on it. That data, it may be cancer prediction through X-ray or that orthopedic I mean prediction, all these things. So is there any validation? I mean, when any thing is running by the government, as you have shown that one device is installed by the government, so obviously there must be some validation. I mean, how much accurate that prediction is in practical ground. I mean, if it is so, then our government. I mean, also in India also we can think about it. Sir, if you just put a focus on it.
Yes, I appreciate your questions. Basically, it's true. So basically, this is the.
Some echo is coming.
Am I audible now? Am I audible now? Yes. So basically, yes. Basically, as a academic AI model, we just create the model. After that, we have a medical team. So basically, these people is the government of Kosovo, is the medical directors to. He has his team to test it, his process. So it's a huge, long verification process. I think it is small implementations. We have to be 7th layer of testing in Kosovo. So it's not that easiest way. Obviously, in India also it is possible, but the problem is that that India medical structure is slightly complicated to get any approval. So it's not easy matter. And second thing is that we can say that all Indians are brilliant. So that is another drawback to implement new things in structures. So if everybody are brilliant, so everybody pull your leg and everybody trying to interfere in your structures. So that is always we are telling that it's not easy to install a new structures in if it is not get a permission from the government. So that's the reasons it's not easy to install in Indian infrastructures, but it's easy to install in that European environment. So this is my observations. It depends the different type of people. So most of the cases we have a doctor team. So they tested, they validate, they approve from the agencies, and they check the how much accuracy. That accuracy level, if it is more than 90 to 93 is enough, they will install. So they allow to people go and come their process. So this is the way we are working. Yes. Any other questions? Thank you. Any other questions from the audience side? Am I audible? Oh, am I audible? It's working. Yes. Any other questions?
Sir, is there any simulator available where we can test our models?
Yes. This 5 code I can give you. You can test your data set. Not a problem. You just email me. I can give this entire code, and you can test your environment. Just only Google Coder is required to test that one.
Okay, sir. Okay, sir. Is there any questions from the audience? So we have acquired extensive insights and impressive demonstrations regarding the applications of artificial intelligence in medical field, and on behalf of everyone here, I'd like to extend my sincere gratitude to Dr. Samanto for sharing such valuable insights with us today. Your expertise, knowledge, and engaging presentation have certainly enriched our understanding, and we are truly thankful for the time and effort you have put into this session. We are sure that the lessons learned today will have a lasting impact on all of us. Thank you once again, sir, for being with us and inspiring us today. Now, as a gesture of honor, we are presenting a certificate to Dr. Samanto, which is being displayed on the screen, and we request our esteemed speaker to accept the same. Is the certificate visible?
Thank you. I appreciate. I accept it. Appreciate.
Okay, thank you, sir. Thank you for your effort and time, valuable time you have spent for us. And our next session will be started from 2:30 p.m. sharp. All are requested to join the meeting on time. The YouTube live link will be shared in the WhatsApp group shortly. Thank you all. Thank you for being patient.
Thank you. Thank you all. Bye. We'll keep in touch. Bye.
Thank you, sir.